So this is the question that you're given a square matrix of size n cross n, and you have to rotate it 90 degrees clockwise, right? Uh,
Yeah.
let's take an example. So if this is your input matrix, the output matrix would look something like this. Okay, and we also talked about that there are two ways to solve this question. One is to use some extra space of order n, n cross n,
Yeah.
and yeah, the second approach is like we can do it without using any additional space. So just by making some changes to the input array, we can create the solution. So we would be looking at both the approaches. First, let me quickly just look at this code that you have shared. So can you just quickly tell me what was the approach that you chose?
To the rotate image.
Yeah, rotate image.
First, I just transpose the array to row column. Then I
Okay,
just
okay.
swap.
Okay, so first you transposed it and then I think you reversed the arrays, right?
No, I just swapped the right and the left column.
Okay, okay. Great. So let's still, if you have worked at it, let's still try to look at both the approaches. And if you learn something new, that's great. Otherwise, we would try to make it short. Like whenever you are given a matrix question and like you are asked to do some modification in the given matrix, right?
Yeah.
So in this case, what kind of modification, what kind of modification are we asked? We are just simply changing the indexes of the values, right? So this one is going to this place,
Yeah.
this two is going to this place, and three is going to this place. So we are not making any changes in the values, but we are only making changes in the indexes, right?
Yeah.
So
Reference.
yeah. Uh, so if we try to write it in the index form, this would be 0, comma 0 index. This should be 0 through first column, 0 through second column. So this was the input array. And now how it got converted into the final output, this 0, 0 was placed here, right?
Yeah. Yeah.
0, comma 1 was placed here. 0, comma 2 was placed here. Similarly, 1, comma 0. Yeah, this was 1, comma 0, 1, comma 1, and 1, comma 2. So now we would try to make a formula to uh, to see how our old indexes got converted into the newer indexes. So 0, comma 0 was the old value, and the new value was uh, this index got to the 0th row and second column, right? 1, 2, 0, 1, 2. 0, 0 index got to 0, comma 2. 0, comma 2 got to 2, comma 2. 2 comma 2 went to second row and 0th column, right? Does this make sense? What we did here? Like what did
Yeah.
we observe here? Okay. So if this makes sense, I think we can see a pattern here. Given any index, take I comma j, its newer value is a j comma
I.
n minus 1 minus I.
Yeah.
Right? So like you can confirm it with any of these above indexes. You will see that this formula is satisfying all the above cases, right? I think the first approach is just was just to get to this point. So if you can find this formula, you can very easily solve it in O of n square, right? In the first case. Now all we have to do is to start a loop I less than n I plus plus, and since it is a square matrix, inner loop would also run until n. And all we have got to do is, but like in this case, we have to create a newer array. We cannot solve it in the given array itself. And why is it so? So let's just try to do it in place. So suppose you don't want to use any extra space and you have figured out that this is the formula, right? You have came to this formula and now you're trying to make the changes in place. So let's see what is the problem that we would face in this case. So what you will do is using this formula, you would try to put this one here, right? This second would go here and this third would come here. Now we would come to the second row, and this would come to this would come to here. This would remain here itself, and this 6, this needs to come here, right?
Yeah.
But we haven't but we have lost this value 6 when we put 2 here. Put this 2 here, so we lost the 6. Like we didn't saved it. So
You
now
can
in the second,
say the temp variable.
yes, but you would if you want to save these things, you would need n number of variables, right? Because you would need to save all the values. Are you getting my point?
Yeah.
So that is why we cannot using this first approach, we cannot solve it in place. All right. So how would we do it? Let's quickly write it. We would create a newer array first, b of size same as the given input array, so n cross n. And here we would simply do this b of using this formula. So what we are doing is in our newer array, in these indexes, I'm placing these indexes from the first array. So b j comma n minus 1 minus I. So are you getting the part that we have started with a empty array b of size a, right? So right now
Yeah, the same
all the
size.
elements in b are 0, and we are just updating its values to I comma j. Okay, so this was the first approach which used extra space. Now let's try to look at the second approach. And actually this
Could you give
approach
me
is
some
very, yeah.
Could you give
What
me
would
some graphical?
in this first approach?
The first iteration, or yeah, the first two iteration. Maybe.
Okay, in this one. So
Yeah.
let's do that. What we're trying to do is, let's say this is the array that is given to us. Same array as previous, 4, 5, 6, 7, 8, and 9, right?
Yeah.
And what we're trying to do is, let me write it here. We have created a newer array B of the same size as our input array, and we would initialize it to 0 or a garbage value. Like it doesn't matter, you can create, right? Yeah. Now what we are doing is we first came up with this formula by making these observations, right? This is you can say this is our pseudocode, right? And now what we are trying to do is using this formula, I'm saying that I am filling my B array, which is empty currently, and I'm using this formula and saying that B j comma n minus 1 minus sorry, I have written it already, right? So let's try to do it, try to fill it one by one. In the first case, when I is equals to 0, right? When the outer loop is 0, first iteration would be j is equals to 0. So b 0, that means 0 row, and n minus 1 minus 0, which would be n minus 1, right? And I'll fill it with a 0 comma 0. In second case, I is still 0 and j is 1, right? Like I is still 0, so it would be n minus 1, right? And this would be replaced with 0 comma 1. When the inner loop when the inner loop reaches till n, right now I is still at 1, right? So in next step j would be 2, I is still 1, so n minus 1, sorry, I is still 0, right? So n minus 1 minus 0, which would be n minus 1 again. It is again a 0 comma 2. After this point, our outer loop has one iteration has completed. So now I would increase to 1, and again this j would run. So in the first case j was 0, in this case j was 1, this case j was 2. Now in second iteration I would be 1, and in the inner loop j would be 0 in the first case. So b b of 0, so it would be 0 and minus 1 minus I, so it would be
n minus 2.
Yeah, n minus 2. A of what is I is 1, j is 0.
Now I get the point.
Yeah, okay. So this was the first approach, right? Now let's try to look at the second approach. In the second approach, this is actually quite interesting, like how we observe the solution here. Let's take the same example. Now I will try to break this problem into two steps. In first step, so let's first look at what would be the final output, right? This is the final output. Okay, so we'll try to break it into two steps. First step would be there's something known as transpose of a matrix. And what does it mean?
Changing the row to columns.
Yeah, changing the rows to the columns and columns to the rows. So in this case, we would start with our input array and we would convert it into an intermediary state where this first column would convert it into the first row. Second column would convert it into the second row. So 2, 5, 8. And this third column would be converted into third row. Does this make sense?
Yeah.
Okay. Now, if we compare this with our final output, what you want, do you see anything? What is happening here?
Yeah.
Yeah, we are just reversing. If you just reverse all the arrays, you would get to the final result. You would get the final result, right?
If we only actually
Yeah, so
reverse
you have to just
the
reverse.
left and the right.
Yeah, 7 would come here, 4 would remain here, and 1 would come here. This is what's happening in our final result as well, right? Just try to compare these two arrays, these two matrices. The first array is reversed, right, in the final result.
Yeah, it's reversed.
Yeah, right.
Yes.
So our first step was to make the transpose of this array, of this matrix, and in second step, I would reverse each row. I think my one note is hanging. Just give me a moment. Like, can you remember that we have done this previously when we were talking about arrays? We saw like how to reverse an array, right? I would share the link of the video in, like, if you don't remember, you can see it is available on YouTube. What we did was, if we are given an array, we saw how we can reverse it. I would not be taking time to explain this. You can revise this from the video lecture. So basically, what you do is, let me just give you a quick recap. You would run.
You can start the counter from the last index.
We have, like, remember, we have to do this in place. Like, that is the whole point of this second approach. So we cannot use any extra space to reverse this array. And like we discussed this previously. So let me just try to give you a recap. Maybe you can remember it. We would run a loop till n by 2. So n is the length of this array, right? We run it till n by 2 and we would swap the ith element with n minus 1 minus ith element using a temporary variable, if you can recall it. So these are the two steps. Using these two steps, we can rotate the image, like rotate this matrix in place, like without using any extra space. So let's now try to write the code for it. So in the first step, I have to transpose the matrix. How would the transpose code look like?
J starts from I.
Yeah, right. You start from I, j less than n, j plus, and we take a temporary variable, save I comma j into it.
I think you can actually declare the thing.
I'm sorry.
Declaring you can declare the thing outside the loop. Every time the loop is actually declaring.
Yeah, but you're right. It does not need to be declared every time. Both things are fine. You can either declare this temp or you can either declare it outside the loops. Because you see, this temp variable is just for storing it temporarily, right? So it is not being used anywhere else. That's why it doesn't make much difference. A So by running this loop, we have successfully
Transpose.
done our first step, which is make the transpose of the matrix. And just to make the point clear, why we started the inner loop with 0. So if you look at this, here's a transpose. So if you look at this diagonal, what we are doing is this is getting swapped with this, right?
Yeah.
This 3 gets swapped with 7.
Yeah.
This 6 would get swapped with 8. So if you run your inner loop also with 0, what would happen is you would again swap the elements. Whatever you have swapped in the
Instead
first
of
iteration, you would
you can you are getting the same.
yeah. If you run it from 0, then you would get the same output. That's why we are running the inner loop from I. Okay, now the second step is we have successfully made the transpose of the matrix. Now in second step, we have to reverse rows horizontally. And this time it would run till n by 2. Similarly, the 2 is okay. So by running this nested loop, we would get our final result. Does this make sense?
I'm good. You can continue.
Yeah, okay. So the first question is done.
So the time complexity will be.
Yeah. Let's look at the time complexity part. We are running two nested loops. So this first loop would be O of n square, right?
Yeah. Okay.
Second loop would again be O of n square. The overall time complexity would be n square plus n square, which is 2 of n square, which is n square, right?